The humble grocer bag, an everyday item often overlooked in its complexity and engineering marvel. At first glance, one might dismiss it as a simple vessel for carrying groceries, but delve deeper, and you'll uncover a fascinating world of engineering and physics at play. Grocer bags are predominantly made from high-density polyethylene, HDPE, and low-density polyethylene, LDPE, two types of polyethylene that offer distinct advantages due to their molecular structure and resulting physical properties. HDPE is characterized by its linear polymer chains with minimal branching, which allows the molecules to pack closely together. This dense packing imparts HDPE with high tensile strength, making it particularly suitable for carrying heavier loads without stretching or breaking. The rigidity of HDPE is a result of its crystallinity, which also contributes to its resistance to punctures and tears. In contrast, LDPE has a more branched molecular structure, leading to less dense packing and lower crystallinity. This gives LDPE its characteristic flexibility and softness, allowing the material to bend and stretch without breaking. This flexibility is crucial for grocer bags that need to accommodate various shapes and sizes of groceries, ensuring that the bag can expand and conform to its contents without failing. The production of these materials involves a process known as polymerization, where ethylene monomers are chemically bonded to form long chains. For HDPE, this process is typically carried out under low pressure using catalysts such as Ziegler-Natta or Metlacin catalysts, which facilitate the formation of linear chains. In contrast, LDPE is produced under high pressure through free radical polymerization, resulting in the branched chains that give it its unique properties. The choice of production method and the resulting molecular structure directly influence the mechanical properties of the final product, demonstrating the critical interplay between chemistry and materials science in the engineering of grocer bags. In the extrusion molding process used to manufacture grocer bags, precise control over temperature and pressure is essential to ensure the quality and consistency of the final product. The molten polyethylene must be carefully extruded through a die to form a continuous tube, which is then rapidly cooled to maintain its shape and structural integrity. This cooling process often involves the use of air or water, and the rate of cooling can significantly affect the crystallinity and thus the mechanical properties of the bag. Faster cooling rates generally lead to higher crystallinity and increased strength, while slower cooling allows for more uniform material distribution and flexibility. The engineering of grocer bags also involves considerations of load distribution and structural integrity. The design of the bag, particularly the handles, plays a crucial role in its overall performance. Handles are often reinforced through techniques such as heat sealing or ultrasonic welding, which bond the layers of polyethylene together to enhance strength. The physics behind handle design involves stress analysis, where engineers calculate the distribution of forces and identify potential points of failure. By optimizing the shape and attachment of the handles, engineers can ensure that the load is evenly distributed across the bag, reducing the likelihood of tearing and improving the user experience. Environmental considerations are increasingly influencing the engineering of grocer bags. Traditional polyethylene bags have been criticized for their environmental impact, leading to the development of biodegradable and compostable alternatives. These new materials often incorporate additives that promote degradation through exposure to light, oxygen, and microorganisms. However, the engineering challenge lies in balancing the material's durability during use with its ability to degrade post-use. Researchers are exploring blends of natural polymers, such as starch or cellulose, with polyethylene to create materials that maintain the desired mechanical properties while being more environmentally friendly. The engineering and physics behind grocer bags involve a complex interplay of material science, manufacturing processes, structural design, and environmental considerations. From the molecular structure of HDPE and LDPE to the precision of extrusion molding and the innovation of sustainable materials, every aspect is meticulously engineered to create a product that meets the demands of modern consumers while addressing growing environmental concerns. The next time you use a grocer bag, you'll understand the remarkable science and engineering that make this everyday item both functional and fascinating. The manufacturing process of grocer bags is an intricate dance of engineering precision, where every step is meticulously orchestrated to ensure the final product meets the demands of everyday use. At the heart of this process lies extrusion molding, a technique revered for its efficiency and consistency. Picture raw plastic pellets being fed into a machine, where they undergo a transformative journey. Through the application of heat and pressure, these pellets are melted into a viscous liquid, ready to be shaped into their final form. The molten plastic is then forced through a die, emerging on the other side as a continuous tube. This tube, still warm and pliable, is guided through a series of rollers that flatten it into a sheet of uniform thickness. Cooling stations swiftly lower the temperature, solidifying the plastic into its desired state. Finally, precision cutting mechanisms slice the sheet into individual bags, each one a testament to the engineering prowess behind its creation. But it's not just about the mechanics, there's a delicate balance of physics at play as well. Consider the importance of uniformity in thickness and strength. As the plastic is extruded through the die, any inconsistencies could spell disaster for the integrity of the final product. Engineers meticulously calibrate every aspect of the process, from temperature control to die design, to ensure that each grocer bag meets rigorous quality standards. This attention to detail extends to the cooling phase as well. Rapid cooling is essential to solidify the plastic quickly, preventing deformation and ensuring dimensional stability. Through careful manipulation of cooling rates and airflow patterns, engineers achieve the optimal balance between speed and effectiveness, resulting in grocer bags that are both robust and reliable. Moreover, the design of the extrusion system itself is a feat of engineering ingenuity. Engineers must account for a myriad of factors, including material properties, throughput requirements, and production efficiency. Complex simulations and mathematical models are employed to predict how the plastic will behave under various conditions, allowing engineers to fine-tune their designs for optimal performance. From the geometry of the die to the configuration of the cooling system, every aspect is meticulously optimized to maximize productivity while maintaining strict quality standards. In essence, the manufacturing process of grocer bags is a symphony of engineering and physics, where precision and innovation converge to create a product that is both functional and reliable. Through the judicious application of extrusion molding techniques and the careful consideration of material properties and design parameters, engineers have transformed a simple plastic pellet into an indispensable tool of modern life. So, the next time you reach for a grocer bag, take a moment to marvel at the intricate science behind its creation. Now, let's talk about the physics behind the design. Ever notice those reinforced handles on grocer bags? They're not just for aesthetics, they serve a vital purpose. The handles distribute the weight of the groceries more evenly, reducing stress concentrations and preventing the bag from tearing. This design feature utilizes principles of structural engineering to enhance the bag's load-bearing capacity. Let's delve deeper into the physics behind the design of grocer bags. The reinforced handles, often overlooked, are actually integral components engineered to withstand significant loads. Consider the forces at play when carrying groceries as the weight of the items exerts downward force on the bag's handles, creating stress concentrations where the handles meet the main body of the bag. Without reinforcement, these stress concentrations can lead to tears or even catastrophic failure of the bag. However, by strategically reinforcing the handles, engineers redistribute the load, dispersing it more evenly across the bag's structure. This principle of load distribution is fundamental in structural engineering, where even minor design modifications can have significant impacts on a structure's overall strength and durability. Furthermore, the material properties of the grosser bag itself play a crucial role in its performance under load. High-density polyethylene, HDPE, and low-density polyethylene, LDPE, are selected for their unique mechanical properties, such as tensile strength, elasticity, and toughness. These properties determine how well the bag can withstand the stresses imposed upon it during use. For instance, HDPE, with its higher rigidity, is preferred for heavier loads, as it offers greater resistance to deformation and tearing. In contrast, LDPE, with its greater flexibility, is better suited for accommodating irregularly shaped items without compromising structural integrity. By carefully balancing these material properties, engineers can optimize the design of grosser bags to meet the diverse needs of consumers while maintaining structural integrity and performance. Moreover, the design of the handles themselves undergoes rigorous engineering analysis to ensure optimal performance. Factors such as handle length, width, and placement are meticulously considered to minimize stress concentrations and maximize user comfort. For example, longer handles help distribute the load over a larger area, reducing the pressure on the hands and shoulders during carrying. Similarly, wider handles offer a more secure grip, preventing slippage and potential accidents. By leveraging principles of ergonomics and biomechanics, engineers strive to create grosser bags that are not only functional but also comfortable and user-friendly. In addition to structural considerations, engineers also take into account environmental factors when designing grosser bags. With increasing concerns about plastic pollution and sustainability, there is a growing demand for eco-friendly alternatives. Biodegradable plastics, derived from renewable sources such as corn or sugarcane, are emerging as viable options to reduce the environmental impact of traditional plastic bags. Furthermore, reusable bags made from durable materials like canvas or jute offer a more sustainable alternative to single-use plastic bags. By embracing innovative materials and design concepts, engineers are working towards a future where grosser bags not only meet the functional needs of consumers but also minimize their ecological footprint. But it's not just about strength. Grosser bags also need to be ergonomic. Engineers carefully consider factors such as handle length, width, and placement to ensure comfortable carrying for users of all ages and sizes. By optimizing these parameters, they minimize strain on the hands and shoulders, making grocery shopping a more pleasant experience. The ergonomic design of grosser bags is a testament to the meticulous engineering involved in their creation. Engineers delve deep into the intricacies of human anatomy, studying the biomechanics of hand and shoulder movements to optimize handle length, width, and placement. Through rigorous testing and analysis, they fine-tune these parameters to ensure that the bags can be comfortably carried by users of all ages and sizes. By reducing strain on the hands and shoulders, they not only enhance the user experience but also mitigate the risk of musculoskeletal injuries associated with carrying heavy loads over extended periods. Furthermore, the ergonomic considerations extend beyond mere comfort. They also influence the overall efficiency of grocery shopping. By minimizing the effort required to carry bags, engineers streamline the process, allowing shoppers to transport their purchases with greater ease and agility. This subtle yet crucial aspect of design can have a profound impact on consumer behavior, influencing everything from purchasing decisions to brand loyalty. In addition to human factors, engineers must also grapple with the laws of physics when designing grosser bags. Forces such as tension, compression, and shear come into play, exerting stress on the materials and structures of the bags. Through careful analysis and simulation, engineers ensure that the bags can withstand these forces without failing, maintaining their integrity even when subjected to challenging conditions. Moreover, the design of grocer bags is not static. It evolves in response to changing environmental and societal pressures. With growing concerns about plastic pollution, engineers are exploring alternative materials and manufacturing processes to reduce the ecological footprint of grocery packaging. Biodegradable plastics, recycled materials, and innovative concepts such as modular designs are being embraced as sustainable solutions to minimize waste and promote circularity in the supply chain. The engineering and physics behind grocer bags are far more intricate and multifaceted than meets the eye. From ergonomic considerations to material science and sustainability, every aspect is carefully crafted to meet the needs of both consumers and the environment. As we continue to innovate and evolve, grocer bags will undoubtedly remain a symbol of human ingenuity in our quest for more efficient and sustainable solutions. Another fascinating aspect is the environmental impact of grocer bags. With growing concerns about plastic pollution, engineers are exploring alternative materials and designs to reduce waste and promote sustainability. Biodegradable plastics, reusable bags, and even innovative concepts like edible packaging are emerging as promising solutions to address this pressing issue. One intriguing avenue of research revolves around the development of biodegradable plastics. Traditional plastic bags can persist in the environment for hundreds of years, posing a significant threat to ecosystems and wildlife. Biodegradable plastics, on the other hand, are designed to break down into harmless compounds through natural processes. Engineers are working to refine the composition and production methods of these biodegradable materials, ensuring they maintain the necessary strength and durability while still being environmentally friendly. Additionally, the rise of reusable bags presents a promising alternative to single-use plastics. By encouraging consumers to bring their own bags when shopping, engineers are helping to reduce the demand for disposable plastic bags and lessen the burden on landfills and oceans. However, designing reusable bags that are both practical and sustainable requires careful consideration of factors such as material selection, durability, and ease of cleaning. Engineers are leveraging their expertise in materials science and product design to create reusable bags that strike the optimal balance between functionality and eco-friendliness. Furthermore, there's a growing interest in exploring unconventional packaging solutions, such as edible packaging. Imagine a world where your groceries come wrapped in a nutritious, biodegradable material that you can eat along with your meal. While still in the experimental stage, edible packaging holds immense potential for reducing waste and minimizing environmental harm. Engineers are experimenting with edible films made from natural ingredients like seaweed, starches, and proteins, harnessing principles of food science and biotechnology to create innovative packaging solutions that are both sustainable and safe for consumption. In conclusion, addressing the environmental impact of grocer bags requires a multifaceted approach that draws upon engineering ingenuity and scientific innovation. By developing biodegradable plastics, promoting reusable bags, and exploring unconventional packaging concepts like edible films, engineers are paving the way towards a more sustainable future. Through collaboration and creativity, we can mitigate plastic pollution and preserve the health of our planet for generations to come. Grocer bags, often taken for granted, are a marvel of engineering ingenuity. The materials used, typically high-density polyethylene, HDPE, or low-density polyethylene, LDPE, are meticulously chosen for their specific properties. HDPE, with its rigidity and strength, ensures the bag can bear heavier loads without tearing, while LDPE offers flexibility, allowing the bag to accommodate groceries of various shapes and sizes without compromising its integrity. The manufacturing process, such as extrusion molding, is a feat of precision engineering, ensuring uniformity in thickness and strength across each bag. Furthermore, The design of grocery bags is not arbitrary but rooted in physics and ergonomics. Engineers carefully consider factors like handle length, width, and placement to optimize comfort and usability. The reinforced handles, often seen as a mere aesthetic addition, play a crucial role in distributing weight evenly, reducing stress concentrations, and ultimately preventing the bag from failing under load. This application of structural engineering principles ensures that grocery bags can withstand the rigors of everyday use while minimizing discomfort for the user. Moreover, the environmental implications of grocery bags cannot be overlooked. With the rising concern over plastic pollution, engineers are tasked with developing sustainable alternatives. Biodegradable plastics, reusable bags, and innovative packaging concepts are just some of the solutions being explored to mitigate the environmental impact of grocery bags. By leveraging materials science and innovative design, engineers are striving to create solutions that balance functionality, durability, and environmental responsibility. In conclusion, grocery bags exemplify the intersection of engineering and physics in everyday objects, from material selection and manufacturing techniques to design considerations and environmental implications. Every aspect is a testament to human ingenuity and innovation. So, the next time you reach for a grocery bag, take a moment to appreciate the intricate science behind this seemingly simple yet indispensable invention.